0. That is a restriction, right? All the x making denominator not equal to 0. Do I make it clear? You want to find all the x values that is making the function making sense, right? How do I make it make sense? Only when what? Denominator not equal to 0.
You just write it like a sentence.
This is the set of all the x value such that denominator not equal to 0. Those kind of x will be in my domain. Is that okay? And then what do you mean by that? Well, you don't need to have this, actually. The reason why I write this is because this is how you understand. Okay? I need to find a restriction about x. The only restriction is I have to find the x that not making denominator equal to 0. Right? How do I find it? So now the problem is how do you find it? I want to find all the values that is not equal to 0. So I will say, well, when it will equal to 0, I just kick those numbers out. When it will make it 0, only those two bad guys, right? So I say kick it out, kick that out. So the whole line will be the domain except those 2 points, right? This will make it denominator 0. That will make denominator 0. So those two x values will not be in the domain. Does it make sense?
It's just the symbols, like it's just the symbols are.
You mean what symbol?
ER or XER.
Oh, you mean here? That means x is an element of the set of real numbers. X belongs to. That is, x belongs to the set of all real numbers. So it's a way to say x is a real number. So it means x is a real number. Okay? Does it make sense now? Why do I include? I did not include. It shouldn't say include. Okay. All right, look. This is a whole line. I'm going to cut at -2. I'm going to cut at 8, right? Why I cut? Because that point, I should take it out. So you cut the whole line to how many pieces? 3, right? All the rest will be okay, right? So this piece will be whatever less than -2. The middle piece is from -2 to 8, right? And then from 8 and...
Isn't the same as doing also the whole sum and product thing? You say that the number with the variable has the, like here, hold on. So you say like for this variable right here, whichever two numbers equals this product and whichever two numbers equals this sum, you put it right here into the whole.
That's factoring. Yeah. That's how you solve it.
Yeah.
Yeah, this is how you solve it. So we already solve it. So we find out what are the numbers making it 0. And those are the numbers we need.
When you write these, the whole bracket thing, that meant from that number and on, right? From -2 and on, going that way.
Right. This is an interval from -infinity to -2.
Oh, okay.
This is an interval from -2 to 8, right?
And you connect them up.
Yeah. It will. You union. Yeah. Okay. Okay, now, can I have all of you look at the
Oh, wait, I'm sorry.
problem 3?
Never mind.
Tell me.
Well, what happens to the 3x minus 2?
Oh, what happened to that?
I was wondering.
Okay, what happened to 3x minus 2? Well, my good friends, if you have numerator and denominator, you want to make sure that fraction meaningful. You don't really care what happened in the numerator. What you care is the denominator cannot be 0. So what happened to numerator? I don't care, right? Numerator could be 0. Numerator could be positive. Numerator could be negative. Numerator could be anything. Is that okay? Just the denominator. Can I have you look at number 5? Okay, number 5 is straightforward. Shh. you try to what? You try to graph the fundamental function absolute value. Okay? And then after you do that, you just need to what? Shift what? Down 5 units. Is that okay? Now to label 3 points, you just say this is 0, 0, and then just choose some points. The easy one here is 5, 0, and here you have -5, 0, right? Okay. Let's look at the problem 3. On the graph paper provided, use the graph to graph -x plus 3 squared plus 2. Okay, what should we do? Okay. For this one, first of all, you have to see the whole function here. You have something square, and outside of it, you have a negative, right? So remember, I usually advise all of you look at the function in a big picture. So you see that this is, since the coefficient is negative, it's facing what? Down. Okay? There is there's a reflection involved. So you will start with x squared. Okay? Now before I continue do this graphing, I want to have some idea about this function. Look at that function. It is facing down. Sorry?
Is it wrong to start with immediately graphing?
No. No, it's good that you graph. It's good to graph.
Something that helped me, okay, so I went into the textbook and I finally discovered the formula. F of x is equal to a parentheses x minus h plus k, exactly. So that I applied that to the function there, and that seemed good.
Okay, so you kind of memorizing what is that vertex by compare what is a pattern, right?
Correct.
Okay, so now I want you to tell me, do you understand why?
No.
Okay, all right. Now we will investigate the reason why. Okay, now look at this. Look at this. What is the value of x? What is the value of x? Well, make this squaring term 0. Tell me, what? Thank you. You're awesome. When x equal to -3, this will be 0. And you like it because then the whole value will become just what? 2. What happens if x is not -3? So if x is not -3, you say, oh, too bad. Then that number plus 3 will be not 0, right? A number that is not 0, when you square, it will be what? Positive. Am I correct? Is that going to be positive? Now, positive number times this negative will be a negative number. 2 with a negative number will be less than 2, right? That's why it's open downward, right? Remember, this is a parabola facing down, okay? So the highest number is 2. And that is the vertex. The vertex happens when x equal to -3. So remember what you have, this hk. It is x minus h. And here is the k plus k, right? So why this is your highest number? Because it's facing down. So that is the highest number. And that happens when x equals to -3. So that is your vertex. That's how you understand it. Then you don't need to memorize. Okay, you will have this form as x minus something. So x minus what? X minus -3. Is that okay to all of you? Okay. Now, how do you graph it? Okay, you will start with x squared.
Do you have to start with that? Or can you start it?
You can start with negative x squared if you want to. Okay? Okay. I want to make it clear to all of you. Okay. Claire just asked that, is that okay if she start with negative x squared? Yes, it is okay. Negative x squared is x squared, but what? You reflect about the x-axis, so you will face what? Down. So yes, it is okay. So let's start with negative x squared. So you will have 0, 0, negative 1, and then negative 2, negative 4, 2, negative 4. Do you see what I'm doing?
Wait, shoot. The tutor messed me up.
Y equals to negative x squared. Yes, you may start with that. Okay? Yeah, you need to do that. Okay, and then what do? You will shift to the left 3 units to obtain this. So shift to the left 3 units. The vertex here is going to move to here, right? Okay, and then you will have this, and this, and this, and this. Okay? Now you will have a parabola like that. Is that okay? This is y equals to x negative x plus 3 squared. Yeah, you may use different color pen will make it, easy. And then what do? By plus this 2, you will what? Shift what? Up. Shift up 2 units. Is it okay now? Okay? All right, now let's look at number 4. What about number 4? Number 4, you need to find the domain. Haha. Domain. This is a square root function, right? So what is important for this radicand? Remember, for square root to be meaningful, the radicand has to be positive or 0, right? Yes or no? Yes. So this is how you write it. Write this down, all of you. You write it x, all the x such that x minus 2 greater than or equal to 0, right? Because that is what? The radicand equal to or greater to or equal to 0. And what does it mean? It means x has to be greater than or equal to 2. In interval notation, it is 2 to infinity. Okay? For x here, how do you graph it? You will start with the fundamental function, okay? Square root of x. 0, you get 0. 1, you get 1. 2, you get 4. And then 9, you get 3. This is y equals to square root of x. And you need to shift to the right 2 units to get square root of x minus 2. Okay, this is y equal to square root x minus 2. And it is right that the domain is starting 2 and up. right? The graph is only starting from 2 and greater than 2. What about the range? What about the range? Look at the graph. It's above or below the x-axis? Above. So means what? It's greater than 0, right? Radical functions is always greater than 0. All right. Now we have number 7. Oh, can we do 12? Number 7 is okay, right? Okay. And number 9 is okay, right? We did a number 9 in class. And number 12. Sorry? Why is not? You can see, if you see, -3 to 0. -2 to 3. -1 also to 0. 0 to -3. Oh, I'm so sorry. X to -3. Okay? So what do you see? If it's 1 to 1, what do you mean by 1 to 1? Tomorrow, you will have definition. Different input. Different input corresponds to different output.
So is it fine if we say each input must correspond to its own input?
No. When you say it's on, it could be the same as other people. Yeah. You should write different inputs correspond to different outputs.
Okay, so
Do we need to go over this one? No. Okay. All right. So what would you like to see is number 12, right? Okay, let's look at number 12. We are going to cover it today here. So I would say,
Is 12 going to be on?
no, I said already. I didn't say that. Oh, 12 will not be. Yeah, 12 will not be. Will be on Tuesday. 12 will be on Tuesday, okay? Tomorrow I will have like 35 minutes for the exam, and then the rest I'm going to review for you for the Tuesday one. So, so you have...
We only have a half an hour for the exam?
It's a short one. I make it... okay. Here is the situation. Instead of making it like a long 1 hour and 10 minutes exam, I kind of like break that into 2 parts. So tomorrow will be only focused on the graphing. Is that good for now for you? Okay? So that you have another focus on the exponential and logarithm for Tuesday. Okay? All right. Okay, now, any more questions? Okay, if not, then we are going to look at the inverse function for exponential. Continue what we had yesterday. Sorry? Any what? Oh, 12 is on Tuesday. We will go over that in a few minutes after that we introduce this. Okay? I try my best to well prepare all of you to get 100% tomorrow. Okay. Now, continue yesterday's 8.2, okay? Yesterday we introduced everybody about what? The exponential function with a base 2 And good news for you guys, for 8.2, there's a solving equation. I will not cover that, okay? So for 8.2 and 8.3 here, we focus on your understanding. What is exponential? What is logarithm? Just what is the definition for them, okay? And how are they related in graphs? That's it. No solving equations at all, okay? All right. So what did we learn yesterday about exponential functions? We will say, can you see? Here? Perfect. Okay. An exponential function is a function of the following form. Okay? What is that form? You would say, hey, it is going to be with the base a to the exponent x. A here is called base. X here is called exponent. Now the variable is in the exponent part. We call it exponential function. Now we have some restriction about a. What is a? A has to be positive. However, a cannot be 1. Is that clear? All right. Now, yesterday we looked at the example for 2 to the power x. Sorry? Can you read this? A has to be greater than or equal to 0. Okay? Is that okay? Yes. All right. Now, let's look at this. The graph for, sorry? Yeah, do this on a graph paper. All right. Graph function f of x equal to 2 to the x. We did this yesterday. Okay? We will do one more time. Do you have questions? Yeah. We'll do this one more time. Okay. Now, can I what? Okay. Let's do one more time. Everybody will draw on your own notes. How do you draw this 2 to the power x? Okay. Remember, I have a table established yesterday. Okay. When x equal to 0, what is the value? 2 to the power 0 is 1. When x equal to 1, what is the value? 2. Great job. When x equal to 2, what is the value? 4. Great job. When x equal to 3, what is the value? What is 2 to the power 3? 8. Okay. So you can see it getting higher and higher, larger and larger with a very Okay, can I move it up now? Yes. Okay. Do you see the trend of the increase? It's getting faster and faster, right? Can I have x to be the negative value? Yes or no? Yes. You have to focus on this because this is so important. Okay, when x equal to -1, the value will be 2 to the power -1. What is 2 to the power -1? 1/2. Okay, so this is 1/2. So it's here. When x equal to -2, 2 to the -2 is what? 1/4. 1 over 2 squared, which is 1/4. We did this yesterday, right? When x equal to -3, what is the value? 2 to the power -3 is 1 over 2 cubed, which is 1/8. Okay, so what do you see? Oh, you see that the value getting closer and closer to 0, but it will never 0, right? It will never touch the x-axis. This is the function 2 to the x. Okay? What is the base? The base is what? 2. That is greater than 1, right? So you can see the higher the exponent, the larger the value. Am I correct? So this function is what? Increasing. It's an increasing function, and it's based on the value of the base because it's greater than 1. Is that okay? Now, is this 1-to-1? Yes or no? Yeah. Yes. Because it's increasing. Because it's increasing, so you pass the horizontal line, right? It will never come back. Do you know what you mean by increasing? Keep going up, keep going on, never come back. So when you do the horizontal line test, you only have one point intersect, right? Okay. So if it's 1-to-1, will this function have its inverse function? So its inverse function exists. All right. Yesterday we learned how to graph the inverse function. How do you graph it? You just interchange the input and output, right? Okay, so can you plot it now by yourself for the next 2 minutes, okay? Try to draw its inverse function. How do you draw it? Well, okay, we will go do together. Okay, I heard some of you say that. No problem.
So you just flip it, right?
Yeah, you don't say flip it. You interchange input and output. Okay? Are you with me?
When does an inverse function not exist?
When does the inverse function not exist? If it's not in 1-to-1. If it's go like roller coaster, up and down, up and down, up and down. Okay? Okay. So 1, 0, 1 will become 1, 0. Okay? 1, 2 will become what? 2, 1. Okay? This is 0, 1. This is 1, 2. This is 2, 4. 3, 8. So now 2, 4 will become what? 4, 2. Thank you. How about 3a will become what? A3. How about -1.5? -1.5 will become 1/2 and -1. Thank you.
So, are you going to put that you want the inverse, or we're just supposed to put the inverse on the test? Are you going to tell us that we need the inverse? Or
I will tell you what to do. Well, actually, this is to let you know the inverse function, and I'm going to give a very beautiful name for this inverse function. It's called logarithm. Yeah. Okay? All right, now, -2, 1/4. -2, 1/4 will become 1/4 and -2. Thank you. And -3, 1/8 will become 1/8 and -3. What do you see? What? I can, no problem. It will be very, very helpful. Sure. Okay? So, for the inverse, how about this? This is the f. Okay? The f inverse, you are going to see 1, 0, 2, 1, 4, 2, a, 3, 1/2, -1, 1/4, -2, 1/8, -3. Right? What did we do? We simply just what? Interchange the input and output. Does it make sense to all of you? Okay. Now let's graph it. Let's graph it.
For the base, you know how the top is, it says 2 is greater than 1?
For this example, later I'm going to show you on the board there, the base is 1/2. Okay? I mean, for this example, oh, how do I get the base? Oh, this is the base. 2 is the base. This is the base. Is 2 greater than 1?
Yeah, but how do you know to put that?
Oh, no, just, I will give you. This is the function I'm giving you. Okay? So for this problem, the base is greater than 1. Only for this problem. Okay? Next, you are going to have base equal to 3. And sometimes you have base equal to 1/4. If it's 1/4, then that will be less than 1. Right? Okay. Sorry?
It comes from the definition.
You mean why? What do you mean? What one?
It's from the definition where it says where a.
The base here. This is my base, right?
How do you know to put the 1 there? Like, why is it 1? Why can't it be like 0?
Because it's part of the definition. The definition says that a has to be greater than 0.
Oh, okay, so it can't be 1 to 0.
Okay? Okay, good. Thank you. All right, now can we plot it? Okay, let's plot it. And we said already yesterday, the inverse functions and the original function, they are symmetric about what line?
45 degrees.
The 45-degree line, that is what you call? It's the y equals to what? X, right? This is the line that we call line of symmetry, right? Which is y equals to x. Is that okay?
I don't understand what the line of symmetry does.
Do we have to
Line of symmetry telling us that if you fold this paper along this dashed line, it's going to be overlapped. Okay? All right. Okay, now,
do we have to put that?
to put what? The line of symmetry?
We have to put it.
If I asked you. Yeah. Okay. So far, so good? If you are going to have, now, this is going to be on the board here. Okay. Just get the idea. You'll have this on your textbook. How about if 1/2 to the power x? Now, 1/2 is what? Less than 1. Is that right? If it's less than 1, the higher the power, the smaller the value, because you keep multiply by half. When you multiply half many times, the thing's getting smaller and smaller, right? A number times half. So it's getting smaller, right? When the power is 0, it is also 1. 0, 1, right? When x equal to 1, 1/2 of 1/2, power 1 of 1/2 is 1/2. 1/2 square is 1/4. 1/2 cube is 1/8, right? Is that getting smaller and smaller? Right? 1/2, 1/4, 1/8, and so forth. But how about when the exponent is negative? 1/2 to the power -1 is taking reciprocal. So what do you get? 2. Here. 1/2 to the power -2. You get what? 4. It's here. So what do you see? It's decreasing. Do you see that? Okay, it's decreasing. All right? So far, so okay? So when the base is less than 1, it is decreasing. Okay? Sorry? All right? So the base is greater than 1, it will be increasing. The base is less than 1, it's decreasing. Is that okay? All right. And it also has its what? Inverse. So you try to interchange x and y, you will get, so this black curve is your original function 1/2 to the x. Now I am interchange x and y, I can find its inverse. So do you see that this red curve is its inverse, right? Okay? For example, 0, 1 will be 1, 0. 1 and 1/2 will become 1/2 and 1. 2 and 1/4 will become 1/4 and 2. 3 and 1/8 will become 1/8 and 3. Okay? And so forth. Is that okay?
If the base is less than 1, then it's decreasing, correct?
That's right. Okay? So you can see this red curve. How did you form it? You just interchange them. Okay? They are they symmetric? Like a smiling face? Is that symmetric about this green line? Can you see? It's like an open flower. Okay? All right. So what I'm talking is, I'm introducing you that there are functions which are inverse of exponential. So we say, what are they called? So we want to give a name. We call this is exponential. So we call the inverse function with another name, and that is called log. Okay, so now we are going to define the log. Okay? That's all you need to know for the Oh, by the way, come back a little bit. Come back a little bit. Okay. Come back. What is the domain here? Domain is what? Can you tell me what is the domain for exponential? All real numbers. Thank you. Wonderful. Right? Because what? You can use either positive or, for all real number will be your... Okay, what about the range? I love that question.
So it says x cannot equal 1?
So that 2 is
No.
1, just a
Look. What is the x? X could be any number. So the domain will be all real number. It's a set of all real number. What about the range? Look at this curve. What is the range? It's above the x-axis. So what is the range? The range is what? Does it touch 0? No. So it is open interval from 0 to infinity. Is it okay? Yes or no? Yes. This is for what? For f of x equals to 2 to the x. Is that okay?
If it doesn't touch 0, why did we put 0?
Can you tell me this is open parentheses? It means I am the neighbor of 0, but never touch 0.
The neighbor of 0,
Okay. All right. Now, I love this class. Okay. Okay. Now let's continue and say we want to give a name for this inverse. Look at this inverse function. Okay. Remember the inverse function, domain become range and range become domain. Can you tell me what is the domain for this inverse function? The domain for the inverse function? Hello, hello. Hello, hello. Look, look, look. Domain for this red curve is all real number. Range for this red curve is from 0 to infinity. When you talk about inverse function, domain become range and range become domain. So I can write down here for f inverse here, what is the domain? You just say the domain for this f inverse is its range. The range for this inverse is its domain. Does it make sense to you guys?
No. Wait. Okay.
Okay. This is the function. This is the inverse function. The inverse function, its domain will be the range of the original function. Okay? Oh, the symbol. Okay. Capital D means domain.
Right. Well, yeah.
I put this subscript to mean this is a domain for the inverse function.
It's like a subscript within a subscript.
No?
It's like D and then
what is that directly below 2?
Oh, that's F inverse.
Okay, I was like,
Okay. So far, okay? All right. Is that okay so far? All right, now we are going to look at 8.3. That's all you need to know about 8.2, okay? Actually, I already talked about 8.3. I just did not tell you the name for this function. This name is called log, okay? So now definition.
The log is the inverse?
Mm-hmm. Okay, definition. On Tuesday, you will have definitions. Okay. The logarithmic function. Now, come back to here. Can you tell me what is the base here? 2. Can you see? What is the base? 2. So, for this inverse, you have to tell it, hey, this is the inverse for the base 2, right? So I call it log, so I have to say log to what base? So you say to the base A. Okay, now you have to tell me what is A, where A has to be positive and what? A cannot be 1, okay? Is defined by, now I'm using a name called log, so I'm going to say, what do you mean? If you're telling me log to the base A, okay, that is the name for the inverse function. So when you say that, okay, this is A to the X. Here is going to be the log with the base A to the X. Okay.
Super slow.
Super slow. I am stopping here. Almost. Okay. I am. Almost. Okay. So when you are talking about here, attention, I am having an X here, and I'm getting you Y here. Remember, okay? Look at this. What do you mean by Y equal to log to the base A of X? So you say, oh, I know. This is here, and that is there, okay? Y is log to the base AX. But remember, that means what? That means when I come back here, what is the base? Tell me, what is the base? The base is what? A. So actually, here I'm taking log, but here I'm taking exponential operator, right? So I am using Y, so that means what? That means what? A to the power Y, right, is X. That means A to the power Y, because going from this direction, you are taking the input to the power. Is that okay? One more time. Can I remove my, because I want to temporarily block this one. Okay. Okay. Remember, when I do this way, I'm taking the exponent, right? When I do this way, I'm kind of like, I'm taking the log means what?
you're decreasing rather than increasing.
Um,
That's it, basically, right?
no, not decrease. No, this is,
Necessarily, that has to be below 0.
look, this is increasing. Can you tell me, what about this? This is also increasing. Okay? You don't call it that way. All right? So for example, can I have you look at this? Log 2 of 8. Okay? So what is that? That you are telling people that, oh, I want to find out what is the power. Okay? What is the power? 2 to that power will give me 8. Can you tell me what is that power? 3. Thank you. So log is to find its exponent. Okay, one more time. Log to the base 10 of 100. What is that? That means the base is what? Tell me, what is the base? 10. I am looking for the power. 10 to what power? Give me 100. 10 to what power? Give me 100. 2. Great job. Great job. Okay? All right, one more time. Log to the base 3, 1 over 27 equals to what?
-3. No,
Wow, yours. Awesome. So quick. All right. He is thinking like the base is 3. What is the power can give me 1/27th, right? So it must be negative exponent. Am I correct?
Yeah.
So it's negative what? 3. One more time. Log to the base 1/2 to the base 1/2 and then 8. What is that? That means the base is 1/2. What is the power? Give you 8. Tell me. So, okay, hold on. This is 1/2, right? This is 1/2. All right. So, you are going to find the exponent to get 8. Am I correct? Yes? Yes or no? Yes. Well, 8 is 2 to the power 3, right? It should be -3, right?
Okay.
Right? Because when you have negative, means you take reciprocal, it becomes 2, right? So far, so good? So now you get some idea about this log. It's just a nickname to call the inverse of this exponential function.
Wait. Nickname to call the inverse?
All right. I'm going to help you review all this tomorrow. But looking at the packet that I gave you for the purple one, can I have you all look at the purple one for now? The purple one, you can see the first function definition, right? So you know you must have a definition for function, okay? You try to give an example. Are you with me?
So the purple one is for Tuesday, right?
No? I just gone through, say, purple one, only few problems for Tuesday. I just said, did you hear? 5A, 5B, yeah, I said already, yeah. Okay, one more time.
No.
You will have composition, okay? How do you compose? Evaluate the functions. You will have the key. I'm going to put that on Canvas. Don't copy right now. I just want you to look at it, okay? So you will, okay, let's look at this C. Oh, inverse. Remember we say inverse? Okay? Inverse function composed with f. Remember what we say. This is f. This is f inverse, right? So if you start with f, so with something, come here, and then take the f inverse, you should come back to itself. Am I correct? So if I start with 91.
Okay, wait.
And then,
I'm sorry. Let's just stop. Okay. This is a lot of information coming out.
oh, okay.
Yeah.
All right, no
It's because like we have a test tomorrow, and I don't want to learn new things.
You don't want to learn new things.
Well, I'm just, for instance, C for number 3. I've never.
Okay, we will talk about C tomorrow.
Yeah.
Okay, forget about C, okay? But But, okay, tomorrow you focus on the graphing. All right, let's look at the graphing part here. This is the graphing that you know. I will put this on Canvas just to let you know. These will be on Canvas, and you have already seen this on Blue Buckets, okay? So, online? It's online. Okay.
Can you tell us what to do tomorrow for the homework? Can you write it down on a board and have like, or is some of it going to be confused?
That would be excellent. Will that be better for you guys for Tuesday? Okay. Tomorrow we just have the first part of the exam on the graphing part. Okay? Focus on that preparation. And then the rest will be on Tuesday. But tomorrow I'm collecting your blue and purple packet. Blue and purple. Okay? Blue and purple. Blue and purple. And there's a thick packet for graphing. Remember? The white packet. That needs to be completely done. Well, that has been done for a long time. I just want you to make sure you complete it. I will put that on Canvas, okay? So it will be clear.